Okay. Okay, please. Okay, we try to complete the development of the simulation model. Okay, ready dah semua? Kejap lagi kita buat kelas ni. Okay, so you can proceed to completely model the simulation. Okay, so you can copy. So please, dah on dah empty. You can refer to the video. Saya dah on empty. Okay, so please copy the inverter circuit from the original circuit given from in MTIM. Boleh maksudnya you dah develop the modulator ya. This part you have you have developed yesterday, right? Okay, now you can extend to construct the rest part, which are the inverter circuit and the measurement unit section here. So where these two parts you can copy from the file given in MTIM. Clear? So kan MTIM punya original saya bagi kan? So please copy. Clear? Ada copy. Kita buka ini. Udah copy dah? Okay. Ini saya punya video. Ini kan saya. Copy from the file given. Okay. Jadi ramai. So you boleh construct dia punya reference. Kau tengok lagi. Baik juga. Ya, okay. Okay, then before this, you apply the constant block, right, to represent the signal for VD and VQ, the reference signal of the modulator, which are VD and VQ. And before this, you apply the constant block. But this time, please change. You replace the constant block. So mean you have to generate the sine wave for VD and VQ, VD and VQ. Okay, so where you can design the sinusoidal wave shape by using the MATLAB function block here. MATLAB function block. Okay, nampak So mean for VD, dia punya signal, the equation of the signal, which are, okay, maybe I can write here. So where your VD, so this is the VD signal, VD equal to, you have VM, right, the peak of the sine wave multiplied by sine omega t, right? So where the omega is equal to 2 pi f, is it right? 2 pi f. Maybe I need to zoom, magnify the image. Nampak So this case I designed the VD signal, which is the sine function, using the function block here. So where these two function blocks require three inputs. Which are U1, U2, and U3. So where U1 is VM, the peak of the sine wave. U2 is what? U2 apa? U2 is frequency 2 pi f. Nampak eh? Sebab you ada omega t. So here is omega 2 pi f. Clear? And U3 is the time. Simulation time. Nampak eh? So means untuk generate the VD signal, so we need to apply this equation where VD is Vm multiplied by sine omega t. Clear? So you kena take note the sign, the term in the bracket must be in radian. It's not in degree. So then to generate the VQ signal, so mean here for the function block, the bottom function block, so where VQ equal to Vm multiplied by sine open bracket 2 pi f Tn. So then you must put minus pi divided by 2. So please take note. The D and Q, the different phase must be 90 degrees. It's not 120 because this is your input is two phase. And two phase, VD and VQ. Direct and quadrature axis signal. So mean the different phase must be 90 degrees. Kalau you apply three phase as an input reference, so means each phase difference must be 120 degrees to each other. Okay, since kita punya modulator, we apply two phase, VD and VQ, so mean the different phase must be 90 degrees. Okay, clear? So means here will be your U1, right? So mean here U1 is your VM. Right? Okay, U2 is your U2 is the frequency, the fundamental frequency. U2 here. So I can extend sekali. Okay, so you have for U3. So this is the time. U3, which is the time. Okay, so mean this case your VM is 50. Your frequency we apply 50 Hz. Okay. So you need to make sure that the VM, the maximum of the VM, you cannot put larger than what? The maximum of VM. What is the maximum? Since your VDC is 120 kan? Since VDC from the assignment given is it right? From the assignment 120 volt. So means here your VM max is what? Ini soalan test tadi. From the test question, VDC divided by square root of 3. Siapa jawab ni betul? Okay. So you need to ensure that your VM here, the value of VM here, you cannot put larger than VDC divided by square root of 3. Someone can calculate. What is the value? Berapa? 120 divided by square root of 3. 120 divided by, so 69, 2820. So here is the maximum value of VM. Okay. If you set the VDC, your VM larger than this value, so all the questions that we have discussed in class are not valid. Dia tak valid. Because for this situation, dia enter to the over modulation region. Because our class, we focus on linear modulation. So that's why we need to ensure that your VM cannot be larger than 69 point something. Okay, so please construct this to design the VD and VQ signals. Remember, VD and VQ are the input reference of the modulator. Bullet is the clock. You just double click to search the component and the block. Clock. Enter. Okay, after you already complete, you construct the model, so then you can run the simulation. Function block. Function block. So this is the function block. Here, function FCN. So maybe you can search. You double click FCN. Ada function FCN. Okay. So, I mean, I said I do the same thing. You just ni, but dia continuously running from 0 to stop time. And don't need to do setting for the clock. My friend. Saya cakap sempat datang kepada yang asli. Amat berasa. Apa? Buat assignment bersama-sama. Ini. Nah, kau susah. Okay, after you completely develop the model, the simulation model, now you can run the simulation. So you may set the stop time. So maybe we can observe or analyze the result for 3 complete cycles. So maybe you can set 0.06 because the period is 0.02. So maybe you analyze the result for 3 cycles. You can start, you can set the stop time as 0.06 second. Here now you can run the simulation. Okay, so make sure that the switching status SA, SB, SE already connected to their respective gate terminal of the IGBTs. So SA for the top switch phase A, SB top switch for phase B, SC top switch for SC. Then for the bottom switches, you need to apply the NOT gate here to invert the signal because this is 3 conduction mode where the switching operation is complementary. Okay, then you measure the phase voltage here. phase voltage, VAN, VBN, VCN using the voltage measurement block. So this one dah provided kan? Okay, dah provided. Where these three signal connect to the scope here. Then you can measure the phase voltage. Tak perlu, ni. Alright. Three phase. Siapa yang dah dapat? Okay. Tengok kan? Oh, lambat. Masuk. Boleh. Jangan. Ini problem. Balik. Ini bisa bermula. Okay, bagus. Very good, very good. Ataupun lain, you copy block modulator yang kita design, tidak bukan original file. Dengan modulator sekali dengan ni. Jadi dua blok kita copy. Yang sekurang dapat. Asal tak ada power emitter. Ada lain. MD. Pindah kat UPS. Sebab dia dah komplit dengan power supply. You can copy the model that design today. It's not the stuff. By experiment. Okay. Kenapa tu? Oh. Okay. Oh shit. Okay, sorry. How to construct the reference signal? Yeah. Since we apply very small simple size, if you want to make it faster, you can increase. But the smaller is greater, you get the more accurate answer. Okay. Okay, terus the scope. But they give you a graphic application. Got a place to that's why you place this part to make it faster. But all the something the scope because you better the calculation
for the graph again, to plot the graph. So better you close the scope in XY graph. Close. Dah, bisa. Dah. Dia tahu. Ini bisa saya ke? Buat, jadi tipu saya. Hebat, saya hebat. Tipu aku. Dah. Tukar komputer. Dia baru. I7. Ya, ada apa saya? Tolak. Ya, minus. Dengar. Siapa yang masalah get the function blocks? So you can copy from the measurement units. Dekat measurement units tu, dia ada function block. You just copy. Terus you have finished, you get the result, then you can leave the class. Dan you boleh tinggal di dalam ni. Tapi dah siap dah. Dah, dapat. Sekarang ni kita nak senang. Yes, Michael. Okay, good. Try block electricity.
Betul tak? Okay.
Okay, to those who have already got the result, so you can verify your design by
Checking the frequency spectrum of the output voltage. Okay. So then you dah completely running, then you get the result. So then after that you can verify your design by looking the frequency spectrum of component of the output voltage. So, okay, so then next step, you double click this block, Power GUI, Power Graphic User Interface, go to the Tools tab, click the FFT analysis. Okay, you just apply the setting that I have provided here. So then click Display button. Okay, then you can see here the fundamental is almost to the VM, right? Almost set to the VM. Because we said VM is the peak of sine is 50. So then you get result. The fundamental will be 49 something. Small error. This is the way you verify your design. So then you can change the VM value 25. As long as VM not larger than VM max. Okay. Yeah.
Kalau tak ada checking, itu send default. Dah dapat dah. Sesuai komponen. Okey, boleh. Dah, boleh. Bukan kali bawah. Ni, downside view high. Di space. Ini sebab video kita refer from the video batu saya di sedikit yang masa moden itu semua dah provided ni yang kita buat video di situ dah kalau ni pot dapat mana dia siap kita beli. Ini dan macam Pak, mana dia buat nak Pak Ayo. Siapa yang siap boleh kemas. Ini isu mesti kemas Cek ni dalam meter. Nanti saya akan buat video tu kita akan buat video kan. Buat penelitian yang penting tu gambar awak. Nanti saya satu gambar. Kita design supaya macam ada video saya tak boleh video kan. Kena ajar penjualan sesi pertanian. Kembali sini. Okay, next week. Okay, for the next week class, so class as usual at BEKE 1. So we start to discuss new topic on rectify, the last topic. Monday. Tuesday. Maybe Tuesday. Evening one. Apa dekat
Bukannya ada lag ada tu?
Saya pergi lab, dia pergi lab.
Ha?
Pergi lab.
Bukan tidak.
Kantun. Dia banyak komitmen. Kerja. Sara adik dia nak sekolah. Tak apa. Alamak. Dah lah rekod ni.